Hey guys, today we are going to learn all about random sampling and population inferences. By the end of this lesson, you should be able to understand how to examine a sample from a population. Specifically, we're going to look to see, is a population sample random? And then once a sample has been collected, we're going to see if we can infer what the entire population consensus would be. Go ahead and get out your notes and be ready to learn. So to begin today's lesson, let's look at what a random sample is. Everyone in the population must have an equal chance of being selected in order for a sample to be random. So for example, a survey is taken of favorite sports in 7th grade, but only girls are surveyed. This is not a random sample. Only one group of people is being chosen to be surveyed. To make this more random, everyone in 7th grade would need to be surveyed. When determining if a random sample is actually random, there's a lot of thought that needs to go into it. So it may seem like at first some of them are random, but you have to think, is somebody being excluded? Is everyone getting the same chance to be surveyed? So we're going to read through some situations below and then determine if the various methods would produce a random sample. We can justify our thinking in the space below. So the problem here says the senior class president would like to host an after-graduation lock-in. There will be games, gifts, and food. In order to decide if people would be willing to buy tickets to attend, she has decided to conduct a survey. She will select 25 students to meet and give input on the prices, food, and ticket price. There are 500 members of the senior class. Her first scenario is that she will select every 10th student as they get off of the bus one morning. At first, this seems like it is random. We're picking some random students in an order every 10th student. However, you have to think, does everyone get to school by riding the bus? That may not be the case in every school. At our school, we have people that are car riders. We may even have people that walk. If it was a high school, there might even be people that drive themselves to school or that get dropped off. So in this case, this is not a random sample. So for number one, this is not a random sample because it only includes bus riders. There could be car riders at the school. The second scenario says she asks her choir director to allow her to survey the choir. I want you to pause and think, are there other people in the school besides just the choir? Press play when you're ready to check. Since there are other people in the school, not everyone is included in the choir. This is not a random sample. Scenario 3 says she meets with the counselor who selects every 20th student on the school roster. This is a random sample, since this includes every student on the school roster that has the same amount of chance to be selected. It is also random because it's every 20th student instead of picking random amounts of students. Scenario 4 says she assigns each senior a number and randomly selects 25 numbers. I want you to pause the video and think about it. Does this give every member of the senior class the same chance to be surveyed? Press play when you're ready to check. Since this survey needs to know about seniors, this is a random sample. Each senior has the same chance of being randomly selected. Scenario 5 says she makes an announcement that people interested should meet in the library after school. When thinking this through, you need to think about, does this include everyone in the senior class? This includes people that are interested, but it doesn't necessarily consider the people that are not interested, since they don't need to meet in the library after school. So this is not a random sample because it only includes students who want to participate. Finally, our last scenario says, a roster of the senior class is printed and each student's name is put into a hat. The principal selects 25 names. Is this a random sample? Pause to think about your answer. Press play when you're ready to check. Since this scenario does take into account every senior, and they have the same amount of chance as being selected out of the hat, this is a random sample. Next, we're going to talk about population inferences. Two things are important about population inferences. Once a sample has been collected from a population, an inference about the entire population can be made by setting up a proportion. And remember that an inference is kind of like coming to a conclusion. And maybe you had to come to that conclusion with just little pieces of evidence, and maybe your inference is backed by some different clues. We can also see that inferences can be used to compare different populations and make predictions. We're going to use the information below to answer these questions. It says, Eastside Middle School conducted a survey of randomly selected 6th graders to determine which elective they were most likely to participate in. The results are shown in the table. So we can see in that table that only 6th grade students were surveyed. And it says that they could choose either Spanish, theater, or art. So 14 students chose Spanish, 20 students chose theater, and 6 students chose art. That can also be seen right here in this chart. So now we're going to use that chart to answer some of these questions. Question A says, how many students were surveyed? We have to do a little bit of thinking here because we have 3 different numbers, but we want to know how many total students were surveyed. So to get the total number of students surveyed, we need to add the total that chose Spanish, the total that chose theater, and the total that chose art. This gives us a total of 40 students. Our second question says what percentage of students surveyed selected Spanish as their elective of choice. Now, we need to dig deep into our brain and think about what we learned about percentages. We know, or should know, that percentages are part out of a whole. And that's what you're going to be doing a lot in this unit with populations, and a lot of statistics is percentages. So for this one, the part is the students that selected Spanish, and in this case, that is 14. The whole amount of students, which we just found out was 40 total students. So 14 out of 40 gives us 0.35. But we have to remember that this is not a percentage, and the question is asking for a percentage. So to do so, we move our decimal over 2 places to give us 35%. Next question says the school estimates that there are actually 350 students in the 6th grade. Using this sample, about how many students can be expected to sign up for art? For this problem, I'm going to set up a proportion. I know that there are 40 total students that were surveyed, and I know that there are 350 total students. So I match those up in the bottom of my proportion. Next, I know that there were 6 students in the surveyed population that chose art. So now I'm going to figure out how many students might choose art in the normal population. Now that my proportion is set up, I can cross multiply and solve. When I do the math and cross multiply and then divide, I end up with 52.5. But we have to think about this in a scenario. We can't have 0.5 of a student, so this rounds up to about 53 students. Part B says again that the school estimates that there are actually 350 students in the 6th grade. This time, using the sample, it wants to know how many students can be expected to sign up for theater. Using what we just did in Part C, I want you to go ahead and set up the proportion for this problem and solve. Press play when you're ready to check. After cross multiplying and dividing, I got that 175 students can be expected to sign up for theater. Question E says, the school decides to drop any elective in which less than 10% of the population has signed up for. Miguel says that since only 6 people signed up for art, it should be dropped. Explain why this is or is not correct. First of all, we need to have some math to back up our answer. We know that in the population that was surveyed, there were 6 out of 40 students that signed up for art. This is 15%. So already this is more than the 10% of the population. However, we've only looked at a sample of students. We've only looked at 40 students in the 6th grade when in reality there are 350 students. This is where the inferences come into play. Since we know that more than 10% of our sample wants art, more than likely more than 10% of our population would want art. Usually, if a sample was picked randomly, then that should be proportional to the total population. So, since 15% of our sample want art, about 15% of our population would also sign up for art. We can infer that based on the information that we have. I want you to go ahead and pause the video and explain why this is or is not correct based on the information that we just talked through. Finally, we have some problems that we're going to mark either false or true based on the data. The first one says that over half of the students at Eastside Middle School will select theater for their elective. We know that out of the 40 students surveyed, that 20 of those students chose theater. Is this over half of the students? 20 out of 40 is exactly 50%. So since that's exactly half, it is false that over half would choose theater. Next it says combined, the Spanish and art classes account for 50% of the elective results. Since it wants Spanish and art combined, we would add the 14 students that chose Spanish to the 6 students that chose art for a total of 20. This is 20 out of 40 of the students surveyed, which is half or 50%. So this one is true. Finally, out of the 350 students at Eastside Middle School, at least 120 will sign up for Spanish. For this one, I would set up a proportion. On the left side of my proportion, I have the data from my sample. 14 students chose Spanish out of the 40 students selected. And we're going to see how many students would choose Spanish if this is proportional to the 350 students at the middle school. After cross-multiplying and dividing, I get 122.5. This is more than 120 students, and since the problem says at least 120 students will sign up, this statement is also true. Now that you've made it to the end of this lesson, tell me, would you prefer shopping in-store or online? By the end of this lesson, you should now understand how to examine a sample from a population. In this lesson, we looked at random samples and thought through scenarios where the sample may or may not have been random. We also looked at making predictions on what could happen in the full population when we looked at the sample that was surveyed. In most of these scenarios, we can set up a proportion because our sample should be proportional to our population. This will help determine how many students, in most of our scenarios we were talking about students, but that helps to make determinations based on the survey what would happen in the full population. Let me know if you have any questions about this lesson. Bye guys!